Hello students, in the previous lecture we have started the topic details to assembly drawing of footstep bearing. We have studied what is the use of footstep bearing. So basically footstep bearing was used to support to a vertical shaft. We have seen the different parts of the footstep bearing assembly. This was the exploded view of the footstep bearing, and this was the assembly drawing of the or the assembled view of the footstep bearing. We have also seen the different components which are present in the assembly of the footstep bearing, that is the body, bush, shaft, disc, pin, etc. We have also seen the quantity in which all the components are present and the material of which they are made up of. Then we have studied the body in detail. We have identified the dimensions such as the height, the length, width, then the diameters of the cylindrical part of the upper part of the body. Then we have seen the dimensions of the rectangular slot, that is this slot which was present on the upside. Now we will study or we will identify the dimension of the next part, that is the bush. Here you can see the bush, the part number 2 is made up of gunmetal and its quantity is 1. Now the bush is cylindrical in shape as the top view is circle. You can observe various circles or circles of different diameters are drawn in the top view. So circles are drawn for cylindrical part. So the bush is basically cylindrical in nature. Now we will first see the total height of the bush. Now the total height of the bush is 12. You can see here 12 plus 15 plus 40 plus 15. So if we add all these dimensions, we will get the total height as 40 plus 15 plus 15 equal to 70. 70 plus 12, 82. So the total height of the bush will be 82. Now we will identify the different diameters of the bush. The bottom diameter you can see, or the diameter of this base, is equal to 68. Similarly, this upper part will have a diameter of 68. So the bottom portion will be of diameter 68 and this top part will also be of diameter 68. Now the next diameter to be identified is the diameter from here to here, that is this diameter. This diameter. We have to identify this diameter. Now if we observe the top view, from the top view we can observe this circle which is drawn is the largest circle of diameter 78. So the largest circle in the top view is of diameter 78. And if we observe this figure, the largest cylindrical part or this largest diameter will be from this end to this end. So the diameter of this part, that is the upper part, will be equal to 78 mm. Similarly, from the top view, we can see the smallest diameter is equal to 50 mm. You can see inside the smallest diameter is what, 50 mm. Now if we observe the bush, the smallest hole present inside the bush is this, that is this from here to here. Now we have here in the figure the half section of the bush is taken. So if we draw the complete section, then we can see or we can conclude that the smallest diameter will be from this line, that is this line, to this center line. So the smallest diameter is equal to 50 mm. So the diameter of this part or this hole inside the bush, that is from here to here, will be equal to 50 mm. So from the top view, the largest diameter that we have identified is 78 mm, which will be the diameter of this part from here to here, that is this upper part. Whereas the smallest diameter that we have identified is 50 mm, which will be the diameter of this hole present inside the bush, that is from distance from this line to this center line will be equal to 50 mm, or half of it, that is 25. Here diameter is given as 50 mm, so the half distance from here to here will be equal to 25 mm. Similarly, the bottom diameter is equal to 68 mm, this diameter, and the diameter of this part, that is this, will also be equal to 68. So this part and this part are identical in nature. So the diameter will be 68 of bottom and this diameter will also be 68. The top diameter is equal to 78, whereas the inside diameter or the smallest diameter is equal to 50 mm. Now from the top view you can observe that two additional circles have been drawn. One circle is of 65 diameter and it is visible from the top view. Now if you observe or if you see this bush from the top, you can see that this hole is visible from the top, that is this hole. This is nothing but the oil hole. or the lubricant hole. So this hole which is visible from the top view will be of diameter 65 mm. Since it is visible from the top view, so it has been drawn with the help of dark line. Now there is one more circle which is hidden. You can see the hidden circle has been drawn. Now the diameter of this hidden circle is not given, so we have to identify what will be the diameter. First we have to identify the part for which this hidden circle is drawn. We have to identify the part for which this hidden circle is drawn. So if we see, this hidden circle is drawn to represent this part of diameter 68. If we observe this bush from the top, we can't see this part which is of diameter 68. So this dotted line is the top view of this cylindrical part of diameter 68. So the diameter of this hidden circle will be nothing but equal to 68 mm. Now the last cylindrical part which is remaining is this one. We have find out the dimension of this upper part, this one, this part which was equal to 78. We have identified the dimension of this part 68. We have identified the dimension of this lower cylindrical part, again 68. We have identified the diameter of this hole which is present inside the bush, that was equal to 50 mm. We have identified the dimension of this upper hole or the oil hole, that is this hole, which is equal to 65 mm. Now the diameter of this part from here to here, it is also cylindrical in nature, but this diameter is not given here. So how to identify? Now if we observe this bush from the top, we can't see this cylindrical part, that is cylindrical part from this center line to this line. This is cylindrical part, we can't observe this cylindrical part. So we can conclude that if this cylindrical part is not visible from the top view, the top view for this cylindrical part should be a hidden circle. Hidden circle, that is, in this top view we have to draw one more circle which will be what, dotted, that is hidden circle. But in the top view only one hidden circle has been drawn, that is this one, and we have already identified the diameter of this hidden circle. The diameter of this hidden circle was nothing but equal to 68 mm. So what can be the diameter of this part? This is also hidden, so in the top view a hidden circle should have been drawn. But if we observe the top view, there is no hidden circle, there is only one hidden circle. The second hidden circle which should have been drawn for this part is not drawn. It means that this diameter is coinciding with some other diameter that is visible from the top view. Again I am repeating that no hidden circle is drawn for this cylindrical part, although it is not visible from the top. So it means that this diameter is coinciding with some other diameter of same dimension. And if we observe carefully, then we can conclude that the diameter of this part will be equal to 65 mm. So this hole which is of diameter 65 mm is having same diameter of as this part. So this part will also have diameter as 65. Students, we have learned that if a hidden line and if a visible line are coinciding with each other, then we always represent the visible line, we never show the hidden line. Similarly here, if one cylindrical hole is overlapping with another cylindrical part and this cylindrical hole is visible whereas this cylindrical part is not visible, so even though this part is not visible, we will not draw dotted line because the circle for this part will be coinciding with the circle for this hole in the top view. So we can conclude that the diameter of this portion is equal to 65, which is same as the diameter of the hole. So we have identified all the diameters, we have identified the height also. Now we can see here snug, a part named as snug. Now snug is nothing but the projection, a rectangular projection which is present on the bush. It is an integral part of the bush. Now this snug is nothing but used to function as a key. Now this snug will get fitted inside the snug hole or the snug recess of the body. In the previous lecture we have seen that the body has a rectangular slot on its top, that is a rectangular slot. In that rectangular slot this snub, which is the projection or the integral part of the bush, will fit inside the whole of the body, which is given on the top. And finally what will happen, the bush will get locked with the body. Now we will see the dimension of this snub. Now dimension of this snub is, the length is 3 mm. We can see the dimension is what, 3 mm, whereas the height here, the height is not given, but we can conclude that in the uh, dimension of the body, the height of the snug recess was given as 8 mm. So this height will also be 8 mm, because this will fit inside the uh, this snug recess of the body. So